So we're going to talk about angles in polygons. A polygon is a many-sided figure. Poly means many, so it has more than two sides. So 3 or more. So first, take some time to draw these 5 different polygons. And then you are going to place your pencil on a vertex and draw diagonals from that vertex to each of the other vertices where possible. So for example, I'm going to just draw a random 4-sided polygon. Kind of messed up right there. But I am going to place my pencil or a pen or whatever on a vertex. And I'm going to draw diagonals from that vertex to the other vertices. But I don't want to count like if I'm going to connect this vertex with this vertex, that's just a side. So I'm thinking like not including sides. So like to connect these 2 vertices, that's just a side of this polygon. So there's really only one way that I can draw a diagonal from that vertex to the other. So I'm just going to choose one vertex and do this for all of the shapes. So go ahead and pause your video, draw these polygons, and then when possible, except for the sides of the polygon, connect one vertex to all of the other possible vertices. Okay, so this is what you should end up with. So basically what we have done is created a bunch of triangles. So what we're going to do now is compare the number of sides of our polygon with the number of triangles that we just created by drawing these diagonals. So obviously, like a triangle, like you can't create multiple triangles by connecting the vertices. There's only one triangle. For a quadrilateral, which is what we call 4-sided polygon, we could create 2 triangles. For a pentagon, which is what we call a 5-sided polygon, we could create 1, 2, 3 triangles. For a 6-sided polygon, which is a hexagon, we could create 4 triangles. For a 7-sided polygon, which is a heptagon, we could create 5 triangles. And for an 8-sided polygon, which is called an octagon, we could create 6 triangles. So I bet you could predict if you had a nonagon, which is 9 sides, how many triangles could you create? You could create 7 triangles. And if you had a decagon, which is what we call a 10-sided figure, you would have 8 triangles. So these words, these names, are something you're going to have memorized. So you need to know a heptagon has 7 sides. You need to know a nonagon has 9 sides. We name polygons based off the number of sides. So it's really important to know those names. So let's sort of think about this. What is the sum of the interior angles in a triangle? If you're going to add up the 3 interior angles in a triangle, we know from a long time ago that those 3 angles should add up to 180 degrees. So what we've done is we've taken these really complicated, mysterious polygons, and we've broken them down into triangles. Triangles are something we're really comfortable and really familiar with. So if there's 180 degrees in each of these triangles, well, if I'm just, like what I'm doing is I'm taking 2 triangles and sandwiching them together. If there's 180 degrees in each triangle for its interior angles, I'm just adding all of those angles together. So it's just 180 plus 180, which is 360. So the sum of the interior angles in every 4-sided polygon, every quadrilateral, is 360. It's 2 triangles times 180 degrees gives you 360. For a pentagon, if you added up all the interior angles, of this pentagon, honestly, it would just be 180 plus 180 plus 180. There's 3 triangles, and I could add up those 3 triangles' angles 3 times 180 is 540. So for a hexagon, it's just, there's 4 triangles in a hexagon, which is 720 degrees. For a heptagon, it's 900 degrees. And for an octagon, it's 1080 degrees. For a nonagon, it was 1260. And for a decagon, it's 1440. So really, to find the total number of degrees, to find the sum of all the interior angles in any polygon, you are taking the number of triangles and multiplying that by 180, because in every triangle there's 180 degrees. So however many triangles there are in your figure, you just multiply the number of triangles by 180, and that gives you this sum, which is what it means to add up all the angles of the interior angles of that polygon. So how does the number of sides on the polygon relate to the number of triangles within the polygon? So there's got to be some sort of connection between the number of sides and, which is n. So we're going to refer from now on, the number of sides of your polygon, we're always going to use the variable n. So the number of sides and the number of triangles are 2 off. So 3 minus 2 is 1. 4 sides minus 2 is 2 triangles. 5 sides minus 2 is 3 triangles. So if you take the number of sides and subtract 2, that gives you the number of triangles. So down here, the number of sides, the number of sides minus 2 equals the number of triangles. So the number of triangles is n minus 2. That's the number of triangles. So if there's 180 degrees per triangle, and we're going to multiply the number of triangles that we have by 180 degrees, that gives us our grand total, the total sum of all the interior angles of our polygon. Then we can just come up with a formula simply by using the number of sides of the polygon. So if there are 180 degrees in every triangle, and there's the number of sides minus 2 triangles in every polygon, then the total number of degrees, the sum of all the interior angles of every polygon can be found by taking the number of triangles minus 2 and multiplying it by 180.